Learn VR MR. Come to the Spatial XR community.
Hello everyone. In this tutorial, I will introduce how to use MRUK to replace objects in the room model. In previous lessons, we used Effect Mesh to render the room model. But sometimes we want to replace certain real objects in the room model with virtual object models that we have prepared. For example, I might want to replace a real door with a virtual door model. In this tutorial, I will show you how to achieve this. First, click on Media in the Unity menu bar. Then click Tools, open Building Blocks, and click on the Scene tab to find the Anchor Prefab Spawner. Drag this module into the scene. Next, select Default View and click Confirm. Unity will then add a new object to the scene, which has an Anchor Prefab Spawner script that can replace certain objects in the environment model. Let's look at some important parameters of this script. First is Spawn on Start. Since the Anchor Prefab Spawner can replace certain objects in the room model and load them, this parameter can control whether to load the room the user is currently in or all rooms scanned around the user. If it is set to Current Room Only, it will load the room the user is currently in. If it is set to All Rooms, it will load all rooms scanned around the user. Next, let's look at the Prefab to Spawn list. In each element of the list, we can specify which room objects with certain labels need to be replaced. For example, there are two elements here. Let's first look at the first element in the list. We can set the labels here to decide which labeled objects need to be replaced. These labeled objects have a common point. They can all be represented by a 2D plane. The prefabs below can then be used to replace these labeled room objects. So it replaces the room objects that can be represented by a 2D plane, such as floors, walls, doors, and windows, with the WALL prefab referenced here. This prefab is located at this position in the project. When we open this prefab, we can see that it is a 2D plane represented by a cube block. The z-axis scale of this block is a very small value, making it appear as a 2D plane. Now let's look at the second element in the list. It specifies objects with these labels, which also have a common point. They can be represented by a 3D cube, such as tables and beds. It replaces these 3D cubes with the other object referenced here, which is a cube object. Okay, now we can try running the program. After entering the scene, you can see that the room model is loaded and the 2D planes in the room model, such as floors and walls, are replaced with the WAL object. We just saw in the Anchor Prefab Spawner script, the 3D cubes are replaced with this white 3D cube. However, these objects still have a blue highlighted material because the effect mesh in our scene is still active. So now the anchor prefab spawner can load the corresponding room objects. And the effect mesh can also load the corresponding room objects. I can expand this room object and randomly select one of them. For example, I select this wall. You can see that under the scene anchor of this wall, there are two child objects. This child object is the wall object generated by the anchor prefab spawner, which is this gray wall. The effect mesh child object is the wall object generated by effect mesh, which has a blue transparent material. Therefore, if we want to use the anchor prefab spawner to generate room objects, we cannot use effect mesh to generate them. Otherwise, two room objects will be generated at the same time. When they overlap, it will create a strange visual effect. I can hide the effect mesh object in the scene, and also hide the effect mesh used for rendering the scene mesh. Now we run the Unity program again. Okay, now you can see that. The room model is completely generated by the anchor prefab spawner, and the objects in the room are replaced with the objects we specified in the anchor prefab spawner. For 2D planes, it is replaced with the WAL object. And for 3D cubes, it is replaced with the other object. If we want to replace them with our own models, we can replace the models in the prefab parameter. You may have noticed that the models we replace have a fixed size. For example, if I select this wall model, you can see that the scale of this model in Unity is all 1. Looking at the loaded room model for this wall model, it represents a 2D plane in the room model. For example, these walls represent the walls in the real room, and the sizes of the real walls may vary. We can also see this from the sizes of the walls in the room model. For example, if I select this wall now, you can see that the scale of the generated wall object here has been modified. The original scale of this wall was all 1, but now the scale of this wall has become this size, which has been enlarged. Therefore, anchor prefab can scale the models that need to be replaced to fit the size of the corresponding real objects. Similarly, for these 3D cubes, Unity will automatically scale these models to fit the size of the real objects. Now let's go back to the anchor prefab spawner script and see how this script adaptively adjusts the scale of the models to be replaced to the size of the real objects. We can see that in the prefabs to spawn list of this script, there's a scaling parameter in each element block, with many options to choose from, and the default is stretch. If this option is selected, the script will stretch the model to be generated to the size of the real object. We can open the script and see that there's a scaling mode parameter, which is an enumeration type with each type, corresponding to a different scaling method, and the default is stretch. We can understand the function of each parameter from their comments. If it is stretch, it will stretch each axis of the object. To match the size of the plane or 3D cube in the room model, that is, to match the scale of the model to be replaced to the size of the real object. If it is uniform scaling, the script will multiply the scale of the model to be replaced by a fixed value. If it is uniform XZ scale, it will multiply the X and Z axes of the model to be replaced by a fixed value. If it is no scaling, the script will not scale the model to be replaced. If it is custom, we can write a custom script that inherits from the Anchor Prefab spawner script and override the custom prefab scaling method in the Anchor Prefab script to implement our custom scaling logic. The script also has a mine mode parameter, which controls the displacement of the model to be replaced. It corresponds to the alignment parameter in Unity, and actually controls the alignment of the model, making some fine adjustments to the model's position. If it is automatic, it will align the position based on whether the real object corresponding to the model is a 3D cube or a plane. If it is volume, which means a 3D cube, it will align the model to the bottom of the 3D cube. If it is plane, it will align the model to the center of the plane. If it is bottom, it will align the bottom of the model to the bottom of the 3D cube or 2D plane. If it is center, it will align the center of the model to the center of the 3D cube or 2D plane. If it is no alignment, it will not change the displacement of the model. If it is custom, similar to the previous custom, we can write a custom script that inherits from the Anchor Prefab script and override the custom prefab alignment method. Now let's go back to Unity. However, if you try to adjust the scaling and alignment parameters, you may not see much difference in most cases. So I will create a special case here. First, I added a new element in the prefab to spawn list, and I prepared to replace the window label. I unchecked the window label in the previous element block, and created a prefab at this location in the project. Okay, this is the object. You can see that the root object of this object has its origin at this position, which is above the cube object. It has a cube child object that actually renders the cube. Then I replaced the real object labeled window with this cube up 3D cube. Next, I modified its alignment parameter to bottom. Then I checked the ignore prefab size parameter. After checking it, it will not consider the original size of the prefab when scaling and making fine adjustments to the position. Okay, I will first show the original effect mesh object for comparison later. I will also change the scaling to no scaling. Then let's run the program and see the effect of the window object. Okay, after entering the program, you can see that the window is at this position. First, I will hide the wall generated by Anchor Prefab Spawner. Now the window is at this position. I will also hide this object. Select this object. You can see that this object is generated at the anchor point of the window and is loaded by Anchor Prefab Spawner. This object is the window object generated by Effect Mesh. Now you can see that the window object generated by Anchor Prefab Spawner is at this position, and its origin is aligned with the bottom of the window object above. Since we chose bottom for alignment, it aligns the bottom of the model to be replaced with the bottom of the window object. So now the window object, which is generated by Anchor Prefab Spawner, has its origin at this position, which is the bottom of the window object. Then let's first exit the program. Now I will change the scaling of this window object to stretch and the alignment to center, so the model to be replaced. We'll have its scale adjusted to match the original window object scale, and its alignment will center the model with the window's center. Then we run the program again. And you can see that the window object is now at this position. First, I will hide this wall. Okay, this object is the window object generated by Effect Mesh, and its coordinate center is at this position. The window object generated by Anchor Prefab Spawner has its center at this position, which is the same as the center of the window object. Okay, you can see that both objects have their origins at the same position. And the scale of the replaced model has also been changed. Then we uncheck the Ignore Prefab Size parameter and change the alignment to bottom and run the program again. Okay, now the object generated by Anchor Prefab Spawner has its origin at this position, but its origin is the same as the origin of the window object generated by Effect Mesh, which looks the same as the previous result. But we have already set the alignment to bottom. So theoretically, the bottom of the replaced model should be at the same position as the bottom of the window object. That's because we didn't check Ignore Prefab Size just now. So it has become this result. So just now, I demonstrated the functions of the three parameters: scaling, alignment, and ignore prefab size. Now I will change my requirement. I only want to replace the door in the room model with a virtual door model that I prepared. So I will modify the anchor prefab spawner script. Since the door is a 2D plane, I will now keep only one element in the list and set the label to door_frame, which represents the door in reality. Then I need to replace the door prefab. I have already imported a door model into the project. Okay, for example, I select this door model and see what it looks like. Okay, it looks like this. Then I continue to display the previous effect mesh and change its label. Since the door object is now generated by the anchor prefab spawner script, I will uncheck the door label in effect mesh. Generally, we use effect mesh together with anchor prefab spawner. If there are specific objects that need to be replaced with our own models, we use anchor prefab spawner. And other objects can be rendered with effect mesh. Then we can run the Unity program and see the effect of the replacement. Okay, now I enter the scene, but you can see that the position of the door is abnormal. The anchor point of the door in the scene is here, but the generated door model is here. So now we need to fix this problem. We first find the door model we added earlier, open the prefab and set its position parameters to 0. Okay, then we can run the program again. After entering the scene, you can see that the position and scale of the door model are normal and match the door in reality. The rotation of the generated model will not change, but its scale will be adjusted to fit the size of the door in reality. And its position may be slightly modified to align with the door in the room model. The parent object of this door is the scene anchor of the door, which has the MRUK anchor script. If a scene anchor represents a 2D plane, the z-axis of this 2D plane will be perpendicular to the plane and point towards the interior of the room. For example, the door_frame object I selected now has its z-axis perpendicular to the door and pointing towards the interior of the room. The rotation of the generated door model will be the same as the original rotation of the door prefab. Okay, the same goes for other 2D planes in the scene. For example, the floor I selected has its z-axis perpendicular to the floor plane and pointing towards the interior of the room. The same applies to other 2D planes. For 3D cubes, the z-axis of their root objects, is also perpendicular to the upper surface of the 3D cube and points towards the interior of the room. Okay, so we just used the anchor prefab spawner script to replace a real door with a virtual door model we prepared. In the official example scenes of MRUK, there's an example scene that fully utilizes the anchor prefab spawner to replace objects in the room with models. We previously imported the MRUK example package. And here is a virtual home example scene. We can open and run it to see the effect. After entering the scene, you can see that it is a virtual room, but the layout of the room and the distribution of the objects inside are generated based on the data of the real room. These objects are all generated by the anchor prefab spawner script. You can see that under each scene anchor in the room model, there are generated objects with a suffix of prefab spawner clone, which are generated by the anchor prefab spawner script. You can see that multiple objects in the scene use the anchor prefab spawner script to replace the room objects with corresponding labels. If you are interested, you can further explore this example scene. That's about it for this lesson. We mainly learned the function of the anchor prefab spawner script. Stay tuned for the next lessons.